Most farmers are consistently motivated by growing produce with a specific quality or with as much yield as possible, whilst also maximising profitability. But whilst the general growing environment is relatively consistent year on year, the climate and weather are almost never the same season to season. Consequently, the way in which we are currently using AgTech or managing productivity means we have little ability to really observe the intricate and highly dynamic interaction between the animal or plant and the full environment, including the weather. This means we often take a reactive approach to managing the farm. And this means that whilst we may be more informed by a certain piece of AgTech, by the time that threat is identified, there is already some loss in quality, yield, or condition. For example, satellite imagery that can identify nutrient deficiencies, or livestock wearables that monitor health, connected weather stations that provide nowcasts for likely inversions, soil and plant sensors that monitor soil moisture and plant stress. Yes, these pieces of technology are helping farmers to identify stress more readily, but not enabling certainty of the appropriate management that maximises productivity. Farmers have an unprecedented access to data, an abundance of AgTech that will continue to create more data. However, that doesn't mean farmers need to drown in data. Beyond just AgTech and devices is digital agriculture. This transformation of data has the potential to drive productivity to the next level for farmers. But to fully realise the benefits, researchers in the industry will need to find robust, simple and efficient ways to combine on-farm generated data, using big data and analytical capability. The result will be a sophisticated decision support tool that will help support farmers to transform the agricultural industry and realise the $20.3 billion increase in production. Digital agriculture technologies, artificial intelligence and machine learning are emerging and concurrently transforming the way data is being used to model crop yield, forecast pasture and feed availability, genetic profiling, etc. This will give users deeper, more timely and accurate information about the status and the potential outcome. The use of raw data collected at the farm level, combined with big data, analytics and computational modelling, will ensure producers have the information needed to identify, manage or address as many of the environmental limitations that constrain output, providing key insights that will bring efficiency, greater profitability and the productivity improvements. There are 4 key types of data analytics. Descriptive analytics focuses on describing what has happened in the past. Looking at yield data is a great example of looking back and seeing where part of the crop yielded well and what parts didn't. Whilst it is interesting, it is really difficult to use this data effectively. The biggest variable in any farming system is climate and season-to-season variability. Farmers are reluctant to fully apply what happened last year to the following season, or another herd, or another pasture field, or even a plot of trees. So yes, this type of AgTech and the associated analysis has been valuable in terms of introducing farmers to data-enabled decision-making, but it has also highlighted the need for greater analytical capability. Diagnostic or real-time analytics describes the current status of production, or what is happening right now. It also relies on the use of AgTech, but more specifically sensors and monitoring technology, to provide the status of remote tank water levels, weather, animal health and weight, crop health or moisture retention. Real-time analytics involves capturing the status and then cloud-based analytical power provides insights to farmers. This has been a pivotal evolution of digital agriculture by allowing farmers to see something that is difficult or impossible to monitor or see, and allowing farmers to proactively manage the dynamic challenges of farming. Predictive and prescriptive analytics is the future of digital agriculture. It has the potential to drive major productivity improvements by utilising multiple data sets, machine learning, artificial intelligence, predictive modelling, and feedback loops that help to identify farm threats before we can see them with our own eyes, and still predict their impact. Furthermore, prescriptive analytics will incorporate a feedback loop system that will further add prescriptive capability. For farmers, this means scenario modelling of the what-ifs. Whilst analytics can seem overwhelming and incredibly complex, the possibilities in the future are beyond what you and I are capable of. Analytical capability is continuously improving and evolving. Researchers and industry are actively working on developing what we call data-rich decision support tools for farmers. However, farmers do have a role to play. Be data ready. This means coordinating data collection and finding simple and effective ways to capture and store operational information, like weather data, yield data, field information, animal or herd records. The capability to create a bespoke decision support tool for a specific animal, a field, a tree, or a patch is just around the corner.